Okay, so we're going to continue with our paper 2. Remember, we did start with question 1 and 2. Now we're going to go to question 3 of paper 2. Question 3, they are saying, in the figure L negative 4, 1, S 4, 5, and N negative 2, negative 3 are the vertices of a triangle having angle SLN is equal to 90 degrees. LN is a line which intersects the x-axis at K. So question 3.1 is saying calculate the length of SL and leave your answer in said form. So when we watch our triangle, the coordinate of the coordinate here is the solution. The coordinate of S is 4, 5, and the coordinate of L is negative 4, 1. To calculate the length of SL, we're going to write it like this. SL is equal. Then we're going to use the formula of the distance between 2 point S and L. I'm going to write the formula like this. x2 minus x1 squared plus y2 minus y1 squared. So let's consider point S to be x1, y1, and point L to be x2 and y2, because we want to calculate the distance SL. So we're going to have here, this is 1 and this is going to be 2. x2 is a minus 4 squared, plus y2 is 1 minus y1 is 4 squared. And then we're going to use the calculator to get this distance. The square root of negative 4 squared plus 1 minus 4 squared let's check. Coordinate. Now there's a here the coordinate of SY1 is negative 5, is not negative 4. So here there's a small mistake here. It's a 1 minus negative 4. So our calculation will be square root of negative 8 squared plus negative 4 we're gonna get 64 plus 16 is equal to 8. So here we're gonna get the square root of 80, and square root of 80 is equal to 4 square root of 5. So this is the answer for question 3.1. The length of SL, and they say we're going to leave our answer in a said form. So now we're going to go to question 3.2. Question 3.2, but they are saying Calculate the gradient of Sn. That's question 3.2. The gradient of Sn. Gradient of Sn. The coordinate of S is 4, 5, and the coordinate of N is -2, -3. So you remember the formula for the gradient of a line. I'm going to remind it here. M is equal to y2 minus y1 over x2 minus x1. We're going to consider S to be the first point and N the second. So y2 is going to be -3 minus y1 is -4, and x2 is -2 minus x1 -4. Using our calculator, we're going to get negative let me say Sn. Coordinate of S is 4, 5. So y2 minus y1. Y1 is not 4, is 5 here. Y2 minus y1. Y2 -2 minus y1 -5. So we'll be getting -8 over -6. So it's going to be -8 over -6, and then we get 4 over 3. So the gradient of the line Sn is going to be equal to 4 over 3. We're done with the first question, and the second, we're going to clean the board and then go to the next question. That is going to be 3.3. Now we're going to take question 3.3. Question 3.3, they're saying calculate the size of angle theta, the angle of inclination of Sn. So here, what are we going to do? We'll say M is equal to tangent theta, and M, we got already previously that the gradient of Sn, we find 4 over 3. So we're just going to take a calculator and get the value of angle theta. Arctangent 4 over 3. So here's the value of theta, there, 53, 13 degrees. So this is the answer for question 3.3. After question 3.3, after getting theta, we're going to the next question, is question 3.4. 3.4, they are saying calculate the size of angle L and S. So if we watch our figure, angle LMS, L is in the second quadrant, and the N is in the third. S is in the first quadrant. So to get the size of angle LMS, we need first to start with the gradient of Ln. Gradient of Ln. The coordinate of L, -4, 1, and the coordinate of N is -2, -3. I'm going to consider N to be like the second point, L the first point. The gradient will be the formula. Let me remind the formula. Y2 minus y1 over x2 minus x1. So here we'll be having y2 is -3 minus y1, negative 1, and the x2 is negative 2 minus x1. x1 is going to be plus 4 here, and we're going to get negative 4 over 2, so we'll get negative 2. With this gradient of ln, we're going to get the angle LNS. First, let's calculate angle LKO. When we check on our graph, angle LKO. Let's find first that angle. Arctangent of negative 2. Here's our value. Then we add plus 180. So the value of angle LKO is going to be equal to 116,565 degrees. This is the value of angle LKO. Now, angle LNS is going to be 116,565 degrees minus this angle, theta, 53,13. And this will be the answer for question 3-4. Let's calculate 116,565 minus 53,13. Then we get 63,44 degrees. This is the value of angle L and S. So we are done with question 3-3 and 3-4. We're going to clean the board, then we'll go to the next question. We're taking the next question, and that is going to be 3-5. Question 3-5, they're saying, determine the equation of the line which passes through L and is parallel to Sn. Write your answer in the form y is equal to mx plus c. So they want us to get the equation of the line which passes through L. The coordinate of L is negative 4, 1. And that line is going to be parallel to Sn. Parallel to Sn. They want us to write this equation in the form y is equal to mx plus c. So remember, if two lines are parallel, they're going to have the same gradient. So the gradient of the line Sn, we know it already. The gradient of the line Sn was 4 over 3. Gradient of the line Sn, 4 over 3. So to get the line, the equation of the line which going to pass through L and is going to be parallel the line Sn, we're going to use the equation of a line passing through a point knowing its gradient. That equation is y2 minus y1 is equal to coordinate, the gradient x2 minus x1. So this is the formula we're going to use to get the equation. Let me put it in a simple way, because here we only have got 1 point. We're not going to consider this y2 and x2. So let's write a formula like this. Y minus y1 is equal to m x minus x1. So we'll consider the coordinate of L to be x1 and y1. Our gradient is given is 4 over 3. So to get the equation of the line which is going to pass through L and going to be parallel to Sn, we will consider this equation. Y minus y1 minus 1 will be equal to 4 over 3. X minus x1, our x1 is negative 4, so it's going to be plus 4. So let's write this equation like this. Y will be equal to 4 over 3 x plus 4 plus 1. So let's consider 3 to be the common denominator. So we're going to have 4 over 3 x plus 4. And here is going to be 3 over 3. We multiply 3 times 1. 3 over 3 will get 1. So now here y will be equal to 4x over 3 plus 16 over 3 plus 3 over 3. This will imply that y will be equal to 4x over 3 plus 19 over 3. So this is the equation of the line passing through L and is going to be parallel to the line SN. We have written it in the form y is equal to mx plus c. Our m here is 4 over 3 and our c is 19 over 3. This is the answer for question 3.5. We're going to clean the board and go to the next question. That is going to be question 3.6. We're going to the next question, and that is going to be 3.6. Question 3.6 is saying, calculate the area of the triangle LSN. Area of triangle LSN. So here we have got two possibilities. We can consider the first formula we know. If you want to calculate the area of a triangle, is half base times height. There's another formula. When you check on your formula sheet, the last page on the formula sheet, there's a formula for calculating the area of a triangle. That is 1 over 2 A times B times the sine of angle C. So we can also use that formula on the one we're having on the formula sheet. But here I'm going to consider this simple one. The area of the triangle is half base times height. I'm writing it like this, half base times height. So if we consider our triangle LSN, we're going to consider the side LS to be the base and the side LN to be the height. We know that SL, we have already calculated it was 4 square root of 5. And if we calculate the distance between L and N using the same formula, we will get that Ln is equal to 2 square root of 5. Distance between L and N, using the formula we have used for LS, we're getting 2 square root of 5. So now, applying the formula I'm having here, half base times height, the area of the triangle LSN will be equal to half base. Our base is 4 square root of 5, and our height will be 2 square root of 5. This will be the area of our triangle. Let's use our calculator. Four square root of 5 multiplied by 2 square root of 5 divided by 2, then we get 20. So the area will be 20 units squared. So question 3.6, the area of a triangle LSN is 20 units squared. Then I'm going to clean the board so that we can have some space for the next question, that is going to be question 3.7. We're going to the next question, and that is going to be 3.7. Calculate the coordinate of point P, which is equidistant from point L, S, and N. The coordinate of point P, and this point is going to be at the same distance from the three points of the triangle L, S, and N. Now, coordinate of P, let's say, is A and B. We need to get the coordinate of P being A and B. So we know that angle L, it was given angle SLN is equal to 90 degrees. Remember, we have seen that in Euclidean geometry, that angle on a diameter is equal to 90 degrees. So as our angle in L is 90 degrees, Sn is going to be the diameter of our circle. Angle on a diameter is always equal to 90 degrees. So point P will be the middle of the side Sn. Middle, let me write here, this is practically the reason. Angle on a diameter is equal to 90 degrees. So angle SLN is equal to 90 degrees. So side SN will be practically the diameter of a circle. Now, P will be the middle of this point, S and N. 4, 5, and N is -2, -3. So P will be the middle of Sn. It's so simple now to get the coordinate of P. Let's write them like this. P, middle of Sn will be having 4 minus 2 over 2. And the other one is going to be 5 minus 3 over 2. And this will be the coordinate of P, being a point which is equidistant from L, N, and S. 2 divided by 2, we get 1. 5 minus 3 is 2 over 2, we get 1. So the coordinate of point P, which is equidistant from L, S, and N, will be 1, 1. So here's the answer for question 3.7. We're going to clean the board and go to the next question. And that question is going to be practically the last one for question 3. The last question for question 3 is 3.8. Question 3.8. The question is, calculate the size of LPS. So remember, we got that P is the middle of Sn when we watch our triangle on the figure. So I'm going to represent them like this. They want us to get the size of angle LPS. Angle LPS. Now, if we watch very well our diagram, you will see that we're going to have two lines which are going to be parallel. Line LP and the x-axis. And we are having the line SN here. This line here is called a transversal, which is cutting the two parallel lines. line LP and the x-axis. So we know that this angle here, this being the x-axis, this was angle theta. Now, point S is up there. Let's say here is our point S, and point N is down here. When you watch your graph on the triangle, S is up and N is down. The point L is here. Now, we know that when in Euclidean geometry, when two lines are parallel and they are cut by a transversal, we'll be having this kind of angle called corresponding angle. These two angles here, we call them corresponding angle. So, corresponding angle, when two lines are parallel, it's going to allow us to get the value of the size of the angle LPS. So what are we going to say? We will say that LPS will be equal to, when we consider the line LP, which is parallel to the x-axis, this angle here also going to be theta. So if we want to get this angle LPS, we'll take 180 minus this theta here, then we'll get this angle. So it's going to be 180 angle theta. We know it already because we have done our calculation. Angle theta, it was 53,13 degrees. And this will be the answer for the last question, 3.8. Let's use our calculator. 180 minus 53,13. We're getting 126,87. 126,87 degrees. This is the value of angle LPS when you watch very well on the triangle. I've made it simple like this so that you can understand that when we are having two parallel lines cut by a transversal, and the transversal is the side SN on the triangle, so to get angle LPS, it will be 180 minus theta, then we get angle LPS. We are practically